We go. Welcome back to another fun-filled, action-packed, non-flipped Algebra 2 classroom video with me, Coach Gu. Unit 9, notes number 5. Today we're going to be doing the introduction to graphing logarithmic functions. Yes, sir. So, before we start, there's a very important concept that you need to get into your minds, okay? So write this down. This is very important that you understand this. Remember, logarithmic functions are the inverses of exponential functions. All right, so we need to be able to find the inverses of both of these functions in order to graph. All right, so try to digest that a little bit, you know? Look at that. Read what it says. Chew it a little bit and digest it. Yeah. What do you mean? You ain't ever going to do that in the future. That's only in high school and possibly only this high school. Remember, logarithmic functions are inverses of exponential functions, okay? That's very important. They are the inverses of exponential functions. So, if I were to ask you, what is the inverse of an exponential function? What type is the inverse of exponential function? Yeah. Okay, yeah. So if I asked you what the inverse of an exponential function was, what would it be? What kind of function would be an inverse of an exponential? Logarithmic, that's right. You need to get that in your mind. So that way you know when they ask you questions, you know what you're looking for. And then conversely, what if I ask you what kind of function is the inverse of a logarithmic function? What is it? Exponential, that's right. They are the inverses of each other. All right, so to find the inverses though, what is the general rule to find inverses? What do you do when you're trying to find the inverses? Whether you have a table or whether you have an equation, what are you trying to do? Right, you switch the x's and the y's, that's right. So to find inverses, you switch the x and the y. Right, and that's always true whether it be, tables on a graph. That's what the inverse is actually doing. You're switching what the x and the y values are from the original to get the inverse. Okay, so let's take a look at some examples. So before we can actually graph, there's two skills that we need to be able to do, and that is to actually be able to find the inverses of certain equations. So for example 1, we're going to find the inverse of these exponential functions. We're going to find the inverse of these exponential functions. So for the first example, if I were to give you y equals 2 raised to the x, I want you to find the inverse of this exponential function. So first of all, let me ask you, what kind of function is an inverse of an exponential function? The logarithmic, yeah. So, can you take this exponential form and change it into a logarithmic form? How? What would you do? Alright, so if you wanted to just change this into a logarithmic form, you would just write x equals what? Not like that. Remember the logarithmic form. That's what we did all yesterday and on the homework. Log base. What the? You're right. Log base 2 of That's right, log base 2 of y. This is changing from exponential to logarithmic because we know that the inverse of exponential is going to be in logarithmic form, right? That's why you need to understand that logarithmic and exponential are inverses of each other. So that tells you, okay, let me take this and change it into logarithmic form because I know the inverse is going to be in that form. But what else do we not account for? This is the exact same thing. We just wrote it in a different way. To get it fully to be the inverse, what else do we have to do? Exactly. And so then what would you end up with? Log base 2? Exactly. So that is the complete inverse equation. Yes, exactly. You see, just like on a graph, remember it's always y equals something? And that's what you got. Y equals log base 2 of x. So this is how you're going to find the inverse of exponential functions. So let's do a couple more examples to get more practice in. Practice. All right, so let's see if you have y equals 3 raised to the x. Can you tell me how I would find the inverse of this exponential function? Right, so first you're changing it into logarithmic form, right? Log base 3 of y. Oh, my colors. Okay? And all we've done right now is rewrite the form. What else do we need to do? So then your final equation is going to be? Of? Right, log base 3 of x. There you go. All right, what if we had y equals 1/2 raised to the x? What is our first step here? You want to write log first? Oh, switch to the logarithmic form, yeah. And so what would that become? 1/2, yeah. Right, log base 1/2 of? Right? And then?
Y equals log base of 1/2 x.
Exactly. Very good. And let's do one final one. One final one for the laughs. All right. If we have y equals 10 to the x. This one's special a little bit, but not really. What should we do with this one? Y equals 10 to the x.
X.
Right, you want to switch it to logarithmic form, which would be what?
X equals log the base of 10.
What happens when you have a base of 10? Yeah, you just write log. Remember, you don't need to show the log base 10. You can if you want to, okay? But remember, you don't have to write it, okay? So just keep in mind that when you don't see anything there, the base is 10. All right, and the final step here would be?
Y equals log x.
That's right, y equals log of x.
Yeah, why would you write 10?
Why don't you? Okay, so let me give you a different example. This is the square root symbol, right? Here's the cube root symbol, right? What's the index on the square root? But does anybody ever write that one? Exactly, it's understood. So that's the same idea here. The understood log is the common log, which is base of 10. Okay? That's just something that, was invented. So yeah, same idea though. It's just notation. Okay, so you have just found the inverse of exponential functions. So that's good. And if I asked you to find the inverse of exponential functions, then you also need to be able to find the inverse of what? What do you think? Logarithmic functions, that's right. So we're going to find the inverse of logarithmic functions. So, for example, if you were given y equals log base 3 of x. Okay, first of all, you want to see what the question is asking you. What kind of answer should you have? What type of function is the inverse of logarithmic? Exponential. So you know your answer is going to be, bless you, you know your answer is going to be in exponential form. So I should take this original equation that's in logarithmic form and change it to exponential form. How do I do that? Yeah. It'll be what? Close, but not quite. So the base is what? 3, right. So the base is going to be 3. What's the exponent, though? It's y. Remember, the log statement is telling you that 3 raised to something gives you x. So 3 raised to something gives you equals x. So 3 raised to the y equals x. Because remember, the log is telling you the answer to a log, it is the exponent. Remember? So we have 3 to the y equals x, and then we're trying to find the inverse. So what do we need to do? Switch the y and the x. So what's my final equation going to be? Right, 3 to the x. Oh. 3 to the x equals y. Now, remember when you're writing graphs and things, it's always y equals something. So the more correct way to write it would be y equals 3 to the x. But it's still the same thing. But this is a little cleaner. All right, so let's do a couple more examples to get the hang of this. Boom. All right, what if you had, this is almost the exact same, y equals log base 2 of x. What should I do first? Two raised to the y, right? We're trying to switch it into exponential form, right? Equals x, right? And then we're trying to make it inverse. So my final 3 raised to or 2 raised to the x equals y. That's right. But let's write y equals. So y or wrong color. Y equals 2 to the x. If you put it the other way, no, it's not wrong. It's just that this is cleaner, especially when you're writing an equation, you know. Boom, there it is. Oh, all right, there it is. All right, so what about y equals log base 0.25 of x? What do I want to do first? Right, 0.25. What do we do there? What is it? What is the step that we're doing? You're giving me the answer, right? But what are we actually doing here? You're not solving necessarily. We're trying to change this from logarithmic form to exponential. That's what you're doing. Because these first 2 steps, that's the exact same thing. It says the exact same thing. It's just in different forms. Okay? Okay, now, to get the inverse, what are you going to do? Right, so then your final answer is going to be? Y equals what? 0.25 to the x. There you go. Good. And one final example. It's going to be y equals log of x. So what are we going to do here? 10 raised to the y. Where did the 10 come from?
You just told us.
What?
Because that's the base of.
Exactly. When there's nothing written there, then the base is 10. Good. Okay, so then the final step here.
Y equals. Can I just equal x?
No, because you have 10 to the.
Wait, what if this one's 10 though?
All right, there we go. So now you know how to find the inverse of these 2 types of functions. So now we have all the skills that we need to find or graph these functions. So turn to the back. So I'm going to show you 2 types of graphing problems. Example 3, we are going to graph the inverse of y equals 2 to the x. Then we're going to find the equation of the inverse. Then we're going to state the asymptote, domain, and range in set builder notation. All right, so make sure you answer all parts of the question. Make sure you know what the question is asking you, what you need to do. All right, so let me make sure we're still recording here. Okay, so example 3, we're graphing the inverse of y equals 2 to the x. What do you do in order to graph an inverse? What steps would you take to graph an inverse? Like, how would you find those points? Graph the original, and then what do you do with that original? Flip what? That's right, exactly. So you can get the points of the original and then switch the x and the y, and that will give you your new points for your inverse. Exactly. So our original is y equals 2 to the x. So this is graphing exponentials, so hopefully you guys remember a little bit of this. So we got the x, right? How do I find the y values? 2 to the x, that's right. Remember, the parent function is always going to be a base raised to x. The base is 2 raised to the x. What? Yeah, domain and range, yeah. Okay, what are your x values that we always use?
-2, -1, 0, 1, 2.
That's right. So the other x values, and which x value is it easiest to start from? 0. Why is 0 easy to start from? It's always 1. Anything to the 0 is going to be 1, right? So when x is 0, we have 1. And then we go positive. So if I plug in 1 for x, it'd be 2. Okay. And when I plug in 2 for x is, as you said, 4. Now that we have the values for positive 1 and positive 2, it's easy to find our values for negative 1 and negative 2. What would they be? 1 over 2 and 1 over 4. Very good. Okay, so now I have these points. This is my original graph. What am I going to do with these? Right, we're going to switch them, and that's going to be the inverse. Because remember, the question says to graph the inverse of y equals 2 to the x. So what are my new x values? Right, and then 1, 2, and 4. What are my new y values? Right. All right, so let's graph these. We've got 1/4. That's like 1/4 of the way between 0 and 1, down 2 because negative 2. 1/2, so 1/2 of the way between 0 and 1, and then down 1 because negative 1. Then we have 1, 0, 2, 1, and 4, 2. So we're going to graph this. Ooh, that's a nice looking curve. Okay, anyways. All right, so there's our graph. That was the first part of the question, right? It said to graph the inverse. We've done that. What is the next part of the question, though? Ooh, you're skipping. See, that's how you lose points, because you're not reading the whole question. What's the next part of the question? Find the equation of the inverse. All we did was graph it. Now we got to find the equation. All right, how do I find the equation of the inverse? That's right. So we take the we take the original equation. We take the original equation and we're going to find the inverse of that. And as you said, Omar, you're going to switch this to logarithmic form. So what would the logarithmic form of this be? 2 to the y. Hang on. That is not changing to logarithmic. Remember, we're trying to... Right, x equals... Yes, log base 2 of y. Now, we didn't do anything except for rewrite it, right, into a different form. Now what do we got to do to actually get the equation for the inverse? Right, we switched the x and the y. So this is why we did the other examples on the front, so you know how to do this. Yeah, so then this is your equation, right? So there you go. You got the points for that part of the question. Boom. Now, The asymptote, right. What is the asymptote going to be? Not quite. -3, so you're telling, well, remember you have to give me an equation of a line. So what is, y equals 0 is this. X equals 0, that is right. Notice how this one, the inverse, it's getting closer and closer to the x-axis but never touches the x-axis. And that makes sense because you guys are saying y equals 0. That's the original asymptote, right? For the exponential. This is the inverse. We switch the x's and the y's. So it makes sense that now instead of y equals 0, we have x equals 0 as the asymptote. All right. Now for the domain. How do I write domain in set builder? Squiggly, the x and the line, that's right.
And then
X.
Or no. It's the negative. Or is it positive?
It's not going to the left side, so it's not negative infinity. You were right. It's x something. All right, guys. On the domain for this, notice what's the cutoff point for the x values? The asymptote says it, right? X equals 0. That's the cutoff point. That's cutting off the x values, which is your domain, right? All you got to tell, look, x and the 0. All you have to tell is your graph greater than that, or is it less than 0? Greater than, yeah, because it's to the right. So all you write is the greater than. Notice how I took the exact numbers from my asymptote, right? X and the 0. All I have to put is the sign.
So if it's on this side, it's less. If it's on this side, it's greater.
Yes.
If it's on this side of the graph, it's less. If it's on this side of the graph,
Yeah. All right, the range. What about the range?
Is it y is less than 3?
No, because it's going to go up, right? There's no asymptote. Negative infinity. How do you write this in set builder? Less than? Less than? Positive infinity. Do you guys recall me telling you that the domain for exponential is always negative infinity to positive infinity? Yeah, this is the inverse, exactly. So instead of the domain always being negative infinity to positive infinity, for this logarithmic function, it's always going to be the range is negative infinity to positive infinity. And there you go. All right, so now we're going to do the last graphing type of problem. This is example number 4. This is a different type of graphing problem. So this one we are going to do graph y equals log of x. Then state asymptote, domain, and range in interval notation this time. Okay, first of all, this question doesn't say to graph the inverse of an equation. Why don't you think this one says to graph the inverse of? Yeah, because this is a logarithmic. It's already the inverse of an exponential, right? So it wouldn't ask you to graph an inverse of exponential. Yeah, that's right. Okay, now what's something else I noticed about this equation? It doesn't have a base, so what is the base? 10. Good, so you can write that in to help you remember, just in case. Okay, and so now we want to graph this graph. But that takes us to another stumbling point. Do you know any points for this graph? No, you don't. If I just say graph log base 10 of x, you don't know any points of that. But how do you think we can find some points for this graph? Right, so why are you all looking over there? Okay. Okay, so as I don't know which one of you said this. Okay, yeah. So as Alejandro said, what we can do is change this back into exponential form because we know how to find points for exponential, right? So we're going to change this equation back into exponential form. So y equals I'm not doing that. Come on now. Log base 10 of x. We're writing the 10 here just to not get confused. Right. If we change this equation back into exponential form, then we'll be able to find some points. We'll be able to find some x and y values. So how am I going to change this back into the inverse? Which would be 10 to the y equals x. That's correct. Now all we've done here is change the form. What else do I have to do? Switch the x and the y. So what do you end up with? That's right. Y equals 10 to the x. Okay, so now doing this will help us find some basic points of what would be the original. So x, and how would I find my y values here? Plug them into what though? What should it be written here? 10 to the x, right. 10 to the x. And what are our x values here? Right, there we go. All right, so where should we start? 0, which would give us the value of 1. If I plug 1 in for the x, what do I get? If I plug in 2 to the x, what do I get? 100, that's right. Now that I have the positive 1 and positive 2 values, it'll be easy to get the negative 1, negative 2. What should it be? Right? 1 over 100. Okay. Okay, anyways, and what do I do with these values now? What do I do with this table? All right, we're going to flip the x and the y's. Remember, this is a table for our exponential graph, right? This is not the log base 10 of x graph. So we're going to switch the x and the y's here. That will give us what we're looking for. X and the y. So what are my new x values? 1 over 100? 1 over 10? 1, 10, and 100. And what are my new y values? Right. Okay, so sometimes, you won't be able to graph all the points. That's okay. Like 1 over 100, that's really close to the y-axis. Negative 2, so like just put your point somewhere right there. 1 over 10 is like still very close to the y-axis. The negative 1 brings you down 1. But 1, 0, we can graph that. 10, 1 is off the graph, but you can kind of guess like it's about over here, right? Now 100, 2, just don't even worry about that one. Clearly that's way off the paper. So your graph should take a super sharp turn right there. Boom, like that. All right. So we have just graphed y equals log base 10 of x. All right. What is the asymptote here? X equals 0, right. That's the y-axis. Boom, right there. Okay, let's do the domain. Remember, this is interval notation. So from where to where does this x go? From 0 to positive infinity. Very good. What are my symbols around 0 and positive infinity, though? Parentheses around both. Wow, why? Right, because you don't actually touch 0. You're getting closer and closer to the 0. That's what the asymptote is telling us. But you're not actually touching it, so that's why we use the parentheses. All right, what's the range going to be? Negative infinity to positive infinity. That's right. And that is the end of this question. Yes. So notice there's two different types of graphing problems. One where they give you exponential form first, and then one where they start you off at the logarithmic form. Now there's two things we want to write down here at the bottom real quick. And there's two things, so don't write too big. One of them is, how are the asymptotes of exponential and logarithmic functions different? So what's the difference between exponential and logarithmic functions asymptotes? Which one's which? Exponential, right? Exponential is the y equals a number, right? And which means that logarithmic is x equals a number. Right? The number can change depending on if your graph's shifting, right? Okay, another way you can think about this is that the exponential asymptote is horizontal, which means the logarithmic asymptote is, that's a number sign. Because the equation is y equals, and then it's a number, right, based on where. All right, and then one more thing is,
Wait, I don't get a horizontal. What do you mean a horizontal?
the asymptote for an exponential graph is a horizontal line like this. Remember, because the normal graph, it was like this, remember? It never hits that horizontal. But on the graphs that we just did, the asymptote was a vertical line. Oh, what the heck? Hang on a second. This thing may or may not have... Okay, so the second thing that we're going to write here is... What? Okay, let's see what color pen I have. Oh! Okay, so the last thing we're going to write here is... How do the graphs of y equals 4 to the x and y equals log base 4 of x compare? What is the relationship between these two graphs? Y equals 4 raised to the x and y equals log base 4 of x. They're inverses, that's right. That's all you got to know. They're inverses. Also, not sure if you guys knew this, but inverses, have you guys noticed that every time we find inverse graphs, they look the exact same shape, right? But they look like they're reflected in some way or turned or something like that, right? Have you guys noticed that? That's because inverses reflect over the line y equals x. Inverses are always reflected over the line y equals x. That's why they look like they're reflected in a certain way or turned a certain way. Because look up here. Look up here. The line y equals x is this line. Where am I color? Okay. I'm getting a... Wait, what? Okay. So, yeah, there we go. All right, yeah, so this is the line y equals x, right? And look, if I were to reflect this logarithmic, right? Look at how that's a mirror image over that line, right? That's what every inverse is. It's a mirror image over that line. That's why every time we've done inverses, it looks like reflection of some sort. But that's what it is. All right, that ends our notes, finally, through all the technical difficulties. So until next time, I'll see you then. Peace!